National Electrical Code Section 210.4b addresses the use of three-pole circuit breakers for single-phase circuits. Specifically, it states that three-pole circuit breakers shall be permitted for use as single-phase, three-wire circuit breakers on alternating current systems where all circuit conductors are intended to be protected. This means that a three-pole breaker can indeed be used to serve three single-phase loads, provided that the conditions outlined in the code are met. Let's break down what this means in a practical context. Firstly, consider a scenario where you have three separate 277-volt lighting circuits. These circuits each require a dedicated overcurrent protection device. Each circuit has a hot conductor and they share a common neutral. In this setup, you could potentially use a three-pole circuit breaker to protect these three individual circuits. Secondly, the key condition here is that all circuit conductors must be intended to be protected. This implies that the circuit breaker must be appropriately sized to protect the conductors from overcurrents and short circuits. For instance, if you're using a 20-amp breaker, the conductors must be rated to carry at least 20 amps, in accordance with National Electrical Code Table 310.16, considering the conductor's insulation type and ambient temperature. Thirdly, the alternating current system is crucial. The code language specifies that this application is for alternating current systems. This is important because direct current systems have different characteristics and requirements. The typical voltage configuration for this scenario is a 480-volt/277-volt system. This is a common voltage found in commercial and industrial buildings. In this system, the voltage between any two hot legs is 480 volts, while the voltage between any hot leg and the neutral is 277 volts. Now let's delve a bit deeper into the practical considerations of using a three-pole breaker in this manner. One important factor is the balance of the loads. Ideally, the loads on each of the three phases should be relatively balanced. This helps to prevent excessive current on the neutral conductor and minimizes voltage imbalances on the system. If one phase is heavily loaded while the others are lightly loaded, it can lead to inefficiencies and potential problems. Another factor to consider is the type of equipment being served. If you're dealing with sensitive electronic equipment, it's particularly important to ensure that the voltage is stable and within the acceptable range. Voltage fluctuations can damage or disrupt the operation of electronic devices. Furthermore, you must ensure that a neutral conductor is properly sized to carry the maximum possible neutral current. A neutral current can be calculated based on the phase current. If the loads are perfectly balanced, the neutral current will be zero. However, in reality, loads are rarely perfectly balanced, so the neutral conductor must be sized accordingly. In addition to the National Electrical Code requirements, it's also important to comply with any local codes or regulations that may be in effect. Local codes may have additional requirements or restrictions that you need to be aware of. Moreover, proper labeling is essential. Clearly label the circuit breaker and the associated circuits to indicate that it is serving multiple single-phase loads. This helps to prevent confusion and ensures that anyone working on the electrical system understands how it is configured. It is also important to select the correct type of circuit breaker for the application. Circuit breakers are available in various types, including standard thermomagnetic breakers, ground fault circuit interrupters, and arc fault circuit interrupters. The appropriate type of breaker will depend on the specific requirements of the circuits being protected. For example, if the circuits are serving receptacle outlets in a dwelling unit, arc fault circuit interrupters may be required. If the circuits are serving outlets near water, ground fault circuit interrupters may be required. In the context of the National Electrical Code, it's important to understand the definitions of key terms. For example, a circuit is defined as a conductor or system of conductors through which an electric current is intended to flow. A branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet or load. A feeder is the circuit conductors between the service equipment or the source of a separately derived system and the final branch circuit overcurrent device. Understanding these definitions is essential for correctly applying the code requirements. Furthermore, the National Electrical Code contains numerous tables and examples that provide guidance on how to properly size conductors, calculate voltage drop, and select overcurrent protection devices. These resources can be invaluable in ensuring that your electrical installations are safe and compliant. When working with electrical systems, always prioritize safety. To energize the circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician. In summary, National Electrical Code Section 210.4b permits the use of 3-pole circuit breakers to serve 3 single-phase loads, provided that all circuit conductors are intended to be protected. This is a common practice in commercial and industrial buildings, but it's important to understand the code requirements and safety considerations before implementing this type of configuration. Always consult the latest edition of the National Electrical Code and any applicable local codes or regulations. Consider the balance of loads across the phases. Ensure all circuit conductors are intended to be protected. Use the appropriate type of circuit breaker and ensure that the neutral conductor is properly sized. And remember, always prioritize safety when working with electrical systems. The typical setup mentioned in the original prompt consists of 3 277-volt lighting circuits sharing a common neutral, supplied by a 480-volt/277-volt 3-pole 20-amp breaker. Each of these points is crucial. Firstly, the 277-volt lighting circuits are typical in commercial settings. Secondly, the shared common neutral is an important consideration for neutral sizing. Thirdly, the 480-volt/277-volt system is a standard voltage configuration. Fourthly, the 3-pole 20-amp breaker provides overcurrent protection. In addition to the code requirements, it is also important to consider the practical aspects of wiring these circuits. Use appropriately sized conductors for the lighting circuits. Ensure that all connections are made properly and are tight. Use proper wire connectors and termination methods. Identify and label all conductors clearly. These steps will help to ensure a safe and reliable electrical installation. When troubleshooting electrical circuits, always use proper testing equipment. Use a multimeter to measure voltage, current, and resistance. Use a clamp meter to measure current without disconnecting the conductors. Use a circuit tracer to identify the path of a circuit. These tools can help you to quickly and safely diagnose problems. Finally, remember that electrical work can be dangerous. If you are not qualified to perform electrical work, hire a licensed electrician. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and correctly. Always follow all safety precautions and code requirements. Electrical safety is paramount.